Alright, so for this set of notes, I'm trying something a little bit different. It might be a little annoying. It might be dumb. I guess we'll see. And if you guys like one way or the other, you'll let me know. Or if you just hate notes in general, I'm sure you'll let me know that too. So this section is about midpoint and distance. These are two formulas you probably might be familiar with, but you haven't taken math in a long time, so who knows the last time you've seen it. Feel free to pause to write down notes if you want. I'm going to try to go through this quicker just because my videos tend to go a little bit long. So what we're going to have is midpoint. It's literally the middle point between two other points. It cuts a line segment in half. So literally, if I have a pen and I want to find the midpoint, I'm just trying to find that point that's exactly in the middle. So then if I cut it in half, which you should know the word hopefully by now is bisect, what you would also notice then is the midpoint, then this side and this side should be exactly the same because it's in the middle. You're just finding the middle, which is the mean. If you remember mean, median, mode, mean is when you just add up how many there are, add up the numbers and divide by how many there are. In this case, there's 2 points. So you're going to add those two numbers up and divide by 2 because there's 2 points, which gets us this formula. Add the x's, divide by 2, or cut in half. Add the y's, divide by 2, cut them in half. So the midpoint formula is the simpler one. I'm not actually going to make you memorize these formulas per se. I'll give you the two formulas for midpoint and distance. You just got to remember which one is which. So just remember cutting in half is the middle, and that's the one that has the divide by 2. So if you look at these 2 points there, what's the midpoint? So if you're starting off, if you're having trouble, if you can't remember, you might want to just label them first. So from that first worksheet we did, remember you walk, then you climb the ladder. So our 2 points are 2, 4, and then 4, -2. This is a formula. What I mean when I say the order of the x's and the y's doesn't matter, you could choose those 2 x's and do 2 plus 4, or you could have done it 4 plus 2, because 2 plus 4 is 6, 4 plus 2 is 6. You get the same thing. So order them however you like. I just did the 2 plus 4 over 2 and the 4 plus -2 over 2. Like I said, you can switch them, won't matter. You get 6 over 2 and 2 over 2, which when you divide, you get the point 3, 1. Then it's usually a good idea just to check your work real quickly. Just plug it in. Just find that point, plug it in, and look at it. Does that look like the midpoint? To me, it does. Mostly, I think my dots are different sizes, and so that kind of makes it look a little bit weirder. If I would just to have given you those 2 points, you could have just eyeballed them, been like, boom, that's the middle. That's possible. It just gets a little bit more complicated because sometimes you'll get decimals and stuff like that. So the midpoint doesn't have to fall in an even number. But when you divide by 2, it'll always be a whole number or a 0.5. One of those two. Just a note that I have, if you look, I've just taken that top dot and counted over 1, down 3. And so hopefully, if you think about it, if I want to go from that middle to that bottom point, what do you think I'll have to do? Go over how far and down how far? And since it's the middle meaning exactly the same, so top and bottom should be the same, you get 1 and 3 again. So that's just another way of trying to figure that out. Just as a note, if you were to just counted from that top one down to the bottom one, it would have been 6. 1, 2, 3, 4, 5, 6, which is why we got that 6 for that kind of that midpoint for that number, and then you cut in half and you get 3. And if you would have went the other way, it counts over 2, and then half of 2 was 1, which is where we got that 1 and that 3. Distance formula. It is a little bit more complicated, but if you can just apply the formula, it shouldn't be too bad. Distance equals the square root of parentheses x2 minus x1 n parentheses squared plus parentheses y2 minus y1 n parentheses squared. And what that does, it literally shows you the straight line distance between 2 points. So not over and down or down and over, it's diagonally how far apart those are. I didn't mention this up there before, but basically that sub 2 and sub 1, those little numbers on the bottom, that just means you're taking different numbers. They're not the same thing. So that's what I mean order doesn't matter. It just means they're different. So I'm going to label those just like I did before. Over 1, up 2, and then over 4, down 2. And then I'm just going to plug them in the formula. Once again, order doesn't matter. Distance equals the square root of 1 minus 4 squared plus 2 minus negative 2 squared. What I mean by order doesn't matter. 4 minus 1 would have been fine, and negative 2 minus 2 would have been fine. You just want to, if I choose the top point first, I should do that for the x and the y. So then you get distance equals 1 minus 4 is negative 3 squared, plus 2 minus negative 2, 2 negatives make a positive. That's why it's a positive 4. You are allowed to just put the whole thing in a calculator, which some of you might like to do. In the calculator, just as a note, put it in as parentheses negative 3 squared, not negative 3 squared. Your answer should always be positive. You should be able to tell if for some reason there's negatives anywhere in your answer. That's bad. You should never have negatives, and calculators are weird that way. So anyway, you get distance equals 9 square root of 9 plus 16, which is square root of 25, which is 5. Now, in case, I wonder if this, okay, cool. You could, if you're really good, just put the whole thing in the calculator. And so, you could type it all in at once. 1 minus 4 squared plus 2 minus negative 2 squared, parentheses, and there's the last parenthesis. You get 5. You don't have to do it that way, but some of you are pretty good with the calculator, and you can just type it in all at once. Let me just show you real quick why I want you to put the parentheses. So negative 3 squared. A negative squared means you times it by itself, so 2 negatives multiplied should be a positive 9. If you don't put that there, it's actually doing the squared first, and then it's going to put a negative in front, which is a negative 9. So never do that without the parenthesis. Boom. Oh, that's what's going on. And then what that means is that diagonal distance is 5 units. Also, I'm blurry for some reason. The autofocus is being strange on my webcam. Not quite sure why. My hand is in focus. Anyway, I'm wasting time. So, one last thing. That's really going to bug me. That actually kind of worked. Weird. If you remember the Pythagorean theorem, and this is optional, you don't have to do this, but some of you might actually find this a lot easier than doing that formula. It's a squared plus b squared equals c squared, where c squared is the hypotenuse, which is the longest side of a right triangle. So it's a, b are the legs, and c. What you could do is use this by just making this a big triangle. And then you're counting over, literally, 1, 2, 3, 4, 5 to get to the corner, 1, 2, 3, 4, 5, 6 to go up. And now you're just going to use a squared. Those pens just appeared there. 5 squared plus 6 squared equals c squared. 25 plus 36 equals c squared. 61 equals c squared. When you're solving to get rid of a squared, you're square rooting, so you get square root of 61 equals c. You could always leave, and this is for anything if you would have done the distance formula. If you get to a square root that's not a nice number, which, I mean, 4, 9, 16, 25, 36, 64, 49, 81, 100, 121, 144, 169, 196, 225, 250, 6289, you know, whatever. You're allowed to leave it as just square root of 61. When you get into further math classes, that's what they're going to want you to do. You could also put it in a calculator, which I'm just showing you, second x squared, then 61. So it's the second x squared button. 61, 7.81 is the answer. And then just as one note, if we would have used the distance formula, so I labeled the points there, I just did the whole thing, got -5, -6, and what I'm showing you here is that that 5 and that 5 basically match up, other than negatives, but when you square them, they become positive. That 6 and that 6 match up. Square root of 25 plus 36, which is what we had over there a second ago, 25 plus 36. Square root of 61, square root of 61. So literally these two are doing the exact same thing. The only difference is one of them you turn it into a triangle, the other one you're just using the points. I can guarantee you on your quiz for this, there'll be at least one question where you can just use the triangle, and there's one where I'll probably just use huge numbers so you can't actually graph it unless you wanted to take a long time to do, like, 73 up or something like that. So, yeah, and that's midpoint and distance formula. So let me know if you like just the video of me doing it, or at least I just figure maybe this way, instead of just hearing me, you can see me. Also my office, which until a week before school is actually an extra bedroom, which is why it's pretty empty. There's not a whole lot here. There's like literally a single picture of an owl over there. And actually, randomly, there's also an owl, oh yeah, over there, which I got at AFN last year. Yeah, and so I need more posters and stuff like that. That's my computer setup, and I guess you can't really get closer to the owl, but got it at the farmer's market. Anyway, coolio. We're done.